All right. Hello, everyone. Today I have the opportunity, and I'm really happy to talk with you, Victor, for the second time. What first was like in my podcast, which is changed to videocast, and right now you are here again. And as I promised, we will have more technical discussion today than just discussion about community and so on and so on and so on. We are both a community people, but still there are things in the community which are interesting as well from the technical perspective. So, Viktor Vedmich, colleague of mine, friend of mine, I hope I can say that. We used to work together at IPAM for a couple of years. We did a couple of things together during some events, some community stuff, and so on. Victor now works for AWS, as you can already see, as a senior developer advocate, and is a big fan and big expert in the Kubernetes area and also Karpenter area. So this is something what we will talk today. But before we start with this, as we are closer and closer to reInvent, so let me ask you, Victor, for one thing which probably you don't want to answer really, but what kind of news you expect during the event?
Good question.
I know.
What I'm expecting. So, my personal. So, if you look at the reinvent, we have a couple of keynotes, like 4 keynotes. The first one it's Peter DeSantis. The second one from our new CEO. It will be Matt Garman. The third one I expected it will be from our VP of generative AI, ML, all of the stuff, Swami. And the last one, but not least one, it's from Werner Vogel. So what I'm waiting for, first of all, Peter DeSantis. Every time Peter bring some amazing stuff. For example, from previous year, he announced about Aurora Limitless, and it's really it's so impressed. Not like to say Aurora Limitless, blah blah blah. I was really impressed how we to work if we have a problem in AWS, how we think big. Because for example, for Limitless, one of the key point to achieve this limitless, because what's the problem with Aurora? It's relation database, and when you work with relation database, it's like what you can do. You can have like master node, for example, main node, where you just like write to this node, and then you have multiple of the read nodes. It's not problem. But what if I want to have multiple write nodes at the same time? There is can be a problem, and how you can achieve it, because you need to make sure that when you write something in one node, it should be the same. Like it's you have some ID of your operation, and there is 4 approaches, and one of them it's time. So by default, for example, if you look at the time, it's NTP protocol, which is not very, I would say, have good performance, because the results of the NTP it's 1 millisecond. And if you look at how many transactions you can have in only 500 transactions per second, it's not very good. And what we did, we did atomic times, separate network just to sync time, and now we can achieve 500,000 operations per second. So I really waiting for what will Peter bring on this reinvent. Again, expected maybe some new database, maybe some new, some amazing stuff, because every time Peter, like, I don't know, it's really, like, every time when I attend reinvent, I said, okay, we raised the bar last year. We bring amazing stuff. What will be in this year? New services, maybe new feature, maybe. But from Peter, some hardware, some interesting, because from other years, if we look at it, it's what's related to the network protocols and how we work with our backbone and achieve very good results from network perspective. It's like every time it's next level of performance. Let's see what Peter will bring to keynote. Another super amazing key person, it's Werner Vogel. He does like a show of his presentation, and he big fan of Matrix. Every time like new T-shirt, like for example today you see like with cut passwords. I also have another T-shirt, don't hate Kubernetes. I was not able to find it now, but yeah, maybe next time if we'll have some other conversation, I will take this T-shirt. I don't know. I think he also will show something amazing and something super great stuff. I cannot say that Matt Garman and Swami will do some worse thing or bad thing. No. Just like for sure, it will be a very big keynote because, especially from Matt Garman, because as you, I believe, know, we have this transition from Adam to Matt in this year, and expected that Matt will deliver also amazing presentation, but not as usual as Vernal, because Vernal is a big show with very interesting announcement related to serverless, DevOps area. What's very familiar to me, and I can say it's one of the most interesting, personally for me. Just one more time, just personally for me, not from AWS perspective. Yeah, what will be new? Who knows? I expected something new from Kubernetes, or maybe not Kubernetes, maybe containers. Who knows? Maybe some changes in Fargate, maybe some changes in EKS. I don't know. Like currently, the world is moving to generative AI, and we need to run inferentia on Kubernetes. And if we need to run inferentia, it means like we need GPU, but it can be not so cheap. I don't know. Let's see. What will be on reInvent.
Yeah, we will see it, and we'll see what will happen.
Are you going to be in person?
Yes, I'll be there for the first time, so I'll be there. Yeah.
It's amazing event. Like every time when people ask me what is a reInvent, I say like you have to be here at least one time in your life to understand what is the scale. Because when people say like AWS can scale infinitely, I would say you have to visit reInvent and see by your own eyes how many people can be in one place. You know, like my biggest, I would say, I super surprised when we have like a lunch during the reInvent. It's like free food again. That's what we discussed before our podcast. And this canteen, it's so impressed because I was not able to see the last table. It's so big that you come in, and I don't know, if you want to go from one side to another one, it can take, 20, 25 minutes.
Okay. That's a huge one. Yeah, so the biggest event I ever experienced was KubeCon. It was 13,000 people, and reInvent is much bigger.
50, 60,000 people at the same time. It's crazy.
And a lot of steps done, right? During the
My
days.
recommendation, if you are going to be the dentist, for me, because I am a AWS employee, I'm not able to visit sessions. It's our rules, customer obsessed. I recommend to spend your time with Chuck Talks, with workshops, with what will not be available after, because most of the breakout sessions will be recorded, and so you can watch them after that. But you have to visit my breakout session. One breakout session, mine.
You'll have it. You got it. I'll be there. I'll be there for sure. And yes, the goal is to talk with as many people from AWS as possible to, to meet new people, to create new contacts, and to learn as much as possible. That's the goal. So we'll see how it will go. Okay. So reInvent, this is one thing. This is something that I'm looking forward to. Really, it will be quite hard end of the year for me. I mean, busy year, maybe not hard, but busy, because KubeCon, then DevOps days, and then reInvent. So yeah, it will be interesting. However, I'm looking forward for it. And I'd like to ask you also about one thing related to how AWS is looking on. I have to mention the community because we both are the community people, right?
Mm-hmm.
How AWS is looking on the community, because AWS is doing a lot of things related to community. For example, I am the community builder. There is a hero programs. There is a couple of other programs. There are things like Cloud Day, right? We had in Poland like 2 weeks ago or something like that, which is generally free event. So how AWS think about things about community, why it is so important, because it is important for AWS, I think, at least.
Yeah, for sure, it's very important. So I would say, so let me maybe make some step back. Who I am. I am developer advocate from AWS. Currently, our whole organization is called not like developer relationship. It's part of bigger organization. We currently call like developer experience. And from our perspective, as usual, it's like also if we look at Amazon, not AWS, we have leadership principles, and one of them is customer obsessed. So for us, it's so important to listen to your feedbacks and how you can have these feedbacks. Of course, you can chat, like one by one with some bigger customers, but it's only one of the customer. What can combine the voice of many customers at the same time, especially from different regions, because different regions, different economy, different products, different needs, I would say, and only one way how you can do it, it's a community. So for our organization, developer experience inside an AWS community, I would say one of the most top priority. For that reason, we have so many different programs and support community as much as we can. And it's a little bit in size, but in next year, I hope we'll see bigger involvement and place how we can collaborate and combine worldwide the whole community. I 100% agree that local community, like based in some city, country, when we're speaking the same language, it's very important. But what's the value also from the community that you can speak and collaborate with other people and also in makes an impact on product from AWS. That's what I hope we will see in 2025 more, because currently AWS Heroes has big voice and impact with feedbacks on service teams related to what we are doing, how we do it. And I know, like, not a big secret, Marcus from Munich, AWS Hero just bring a lot of on the table to service team, because he cover like he's CTO, not CTO, but chief AWS officer, something like that. So big position in his own company, but at the same time he bring, like, he's a voice from Germany to the whole AWS and say many very important stuff. What you as a day-to-day developer and have like challenges, you see opportunity to improve some services. It's what I expected we will see more in 2025. More involvement with community, and definitely we will contribute and like invest more time and money to community for sure. Just like it's very important. Why? One of the most important part, like I said, feedback. Another one, it's scaling. Scaling, that's it's very difficult to teach people other, but through the community you can do it by yourself. Like, I mean, in community you can combine together in small groups or ask questions from other engineers, developers, DevOps, I don't know, cloud engineers, SRE guys, and so on, and share this experience. Community is the best way how you can share your knowledge and learn some new stuff. For that reason, for AWS community, it's very, very, very important.
So who am I to not agree with you here? All right. So coming back to your T-shirt, I see there is a cat, right? I saw that your cat walking somewhere before we started, and I also have cat on my T-shirt. So
okay. This is my cat. I mean, like my cat. He's almost all of the time together with me, try to help me. Not bother him.
Beautiful one. Okay, so folks, now we will go in a minute to the more maybe more interesting part. So Viktor is kind enough to share with us some stuff about EKS and Karpenter, and there will be a presentation, there will be a demo, and this demo and presentation is a separate video which will be linked somewhere there. You know the drill. And now we finish this part for the videocast. So thank you very much, Viktor, for this part. And we see each other in the separate video, which will be like a continuous part of this previous part. So it will look a little bit strange that I said thank you and that thing in the middle, but well, it is what it is. So we are ready to start, Viktor, your presentation. I'm looking forward to this because I'm really interested what you prepared for us. Yeah, the stage is yours. I'm giving you the screen, so now we can go with you.
If you have any questions, just in case, you can jump in and ask. So, what I'm going to speak today, let me maybe start from this slide. Karpenter. I'm a big fan of Kubernetes because in my own vision, I think Kubernetes it's new Linux. It's a new way how we run, how we operate with our applications. And it's so important to scale your Kubernetes clusters more efficiently on the right way. When I say it in the right way, that you can control many stuff. And also be more cost effective, because sometimes we run big Kubernetes clusters, spend a lot of money on them, and at the end of the month, just like, oh my God, our Kubernetes cluster cost, I don't know, thousands of dollars. What we can do? First of all, look how you consume your resources and look how you scale your resources, especially we have like scale out, but what about scale in? Just like to back to the normal situation. And in general, when we speak about scaling in Kubernetes, I would say we have two different options. The first option is how we scale our application. I mean, inside in one cluster, we still can scale somehow application. And from other side, it's how we scale outside of the existing resources and add additional resources to our Kubernetes cluster. Inside in the cluster, horizontal pot autoscaler, it's so popular. I know like many people use it because it's so easy to scale out of your application and add additional ports. For example, vertical pot autoscaler, very great tool if you don't understand how many resources you will need, especially from the size of the your pod. One of the most common use cases, what I saw, for example, to Java application, when people don't understand how much memory I need for my application, and vertical pot autoscaler can help you to adjust to the right. And KEDA, it's KEDA. I know that's yes, thank you. It's KEDA event-driven autoscaler. So if you have, for example, some queue or some other metrics, can be very complex metrics, and based on this metrics, you can scale your application. For example, I know currently in your queue, SQS, for example, or other services, up to you what you prefer. You understand, okay, I currently in my queue is like thousands of the messages. I need to spin up additional ports to proceed all of them. But how we scale outside of the Kubernetes, I mean, like how we add additional resources. There are currently two main approaches. The first one, I would say more traditional, it's cluster autoscaler and Karpenter. Definitely, I want to speak more about Kaprenter because Kaprenter it's open source, it's new, it's fresh, it's have very like a lot of flexibilities, and as already Pavel mentioned, I have demos. I said demos, a lot of demos, like 3 demo. So, but first of all, let's look what exactly cluster autoscaler, how it works. Like in super high level, it's super simple explanation. But anyway, so for example, I have a couple of the pods currently in the pending state. So I request new resources, and inside in the Kubernetes cluster, we don't have enough resources to schedule these pods. We remember Kubernetes scheduler understands how many free resources I have inside of the Kubernetes cluster, and if you have 3 of them, like we can schedule on 3. But currently, some of the pods is pending. Cluster autoscaler go to some abstraction which called not group. This not group communicate with ISG after scaling group, and only after that we communicate with EC2. Not limitation, but biggest recommendation for node group to create one node group with the similar size of the node. For example, for CPU, 8 GB of memory. It's for one type of your load. So, for example, to run new 2 pods, we need additional node. We schedule it, and we can run this pod inside in this node. If you look from visual perspective, how it works, for example, I requested new resources currently in the pending state. Scheduler understand, okay, I have currently some free spaces. It's here and here. So what scheduler will do, it's identify its free places and put this pod inside in this node. But what about other 5 pods currently? For abstract, like for simplest way, let's think that's one pod, that's one CPU, for example. And what will happen, we will request additional 2 nodes because, as I mentioned, our best practice is to have the same size of the nodes. So all of them, like currently 4 CPU with some amount of memory. And what's the problem here? That's only 25% of this pods currently busy. Other than like it's idle, so we still have to pay for that. It's one of the reasons why sometimes people say, hey, your cloud, it's so expensive. My first question, how you work with your resources. It's very important to make sure that you consume the right amount of the resources. Okay, what about Karpenter? The same example. Sorry. Before the same example, let's look in mechanism. So previously we discussed, like, for example, HEPA, VEPA, for example, or KEDA. We have pending pods, classes killer ISG, and then EC2 API. But what about if we just remove this ISG? The same what happened when Kubernetes decided to remove Docker and use containerd directly to container runtime. So we will put a Karpenter as on the middle layer to communicate directly with EC2 API fleet instances and understands what's currently is free, what's available inside an AWS, and what will be the best resource currently can fit your load. And also, we can consolidate them together. When I say it consolidate, I will explain a little bit later what is it. But let's see again the same example. We have some amount of pods. We found like 3 places where we can put it, scheduler job, and still we have 5 pods in pending state. And what's Kaprenter will do? We'll try to find the best node to fit this load, and scheduler will do his job to put these pods inside in this node. Great, amazing. That currently in this situation, as you can see, just like idle of the resources, what we have to pay, it's much less to compare to the previous example. And during the demo, I also will show you how it looks like from real load. But from my point of view, sometimes to scale out and compare, for example, Kaprenter and Cluster Scaler, I mean, like from performance perspective, who will be faster to add additional resources? Kaprenter, yes, will win, but the difference will not so big, like maybe 10%, maybe 15%, maybe 20%, depending on what size of the nodes, what's the current load inside an AWS, like many factors. But anyway, it will be faster. But what about if we want to scale in? Like we have enough resources and currently we're done, and we want to remove all of them. So we want to make sure that these free resources, we don't to pay for these resources. So just let's imagine the situation that we done with this load, and Kaprenter will very quickly identify these free resources. And as we don't work with ISG and other resources, Kaprenter know like this free node currently is free. We have some daemon set, for example, some system pods, let's say in this way, but it's not available load currently on this node. And Kaprenter just like run the classical way, drain this node and remove it all from our cluster. And also, another part, again, it's consolidation. I will explain a little bit later, but in general, like we can run constantly and see how many resources we have inside the cluster and how many of them really needed to run our load inside the cluster. Not like recent changes, it's like from last year, but still for some people who use Kaprenter, it's very important because we made not backward compatible changes. It's breaking changes in schema, API schema of Kaprenter. Currently, for today, our version 1.0.3. It's stable, and we are not expecting any more breaking changes. But what's really happened? Karpenter moved from AWS repository to official CNCF repository to SIG of Kubernetes. Currently it's a part of Kubernetes ecosystem in GitHub. And Karpenter currently as implementation you can find for AWS for sure and for Azure. It's very important because it means like you can use this scalar mechanism not only inside an AWS. And also, I saw some activity inside on GitHub. People started to create their own implementation for other cloud providers, for other hosters, and so on. Maybe we will see something for VMware and like for on-premise and so on. What kind of resources we can configure inside in Karpenter? How it works? So first of all, it's not pull. I understand it's like a little bit too much from right side, left side, like as you can see, this code. Let's go a little bit deeper. What you can configure. So first of all, you can configure what the CPU architecture, classical, for example, like Intel or AMD. So it's 86 or ARM. It's our own processors, Graviton, which will be much cheaper and have a lot of benefits. If you don't familiar with Graviton, spend your time a little bit because maybe you can migrate to Graviton and save your money and also be more sustainable because it consumes much less electricity for the same performance. Another options. So what can be super important for many of us, it's purchase options. So we remember that it's on demand. It's can be not so cheap, but spot instances have a big discount, like up to 80%, but mostly like 60%. It's like it's usual situation that's 60% cheaper compared to on-demand of instances. So maybe you need to run on. You can run your application inside on spot instances. That's cool. So we can save some money. But what about spot instances? Spot instances, it's if some of the bigger customer, for example, Netflix, released a new show like Witcher 3, for example. Short season, or I don't remember. Anyway, it's like some new show, right? It's very, very popular, and now they need all of the resources in this region to spread their content and so on. And they're ready to pay 100% of these instances. So previously, you have to manage it by yourself. How to consider with this? That's not spot instances will not available just like in 2 minutes. Currently, is built-in spot instances interruption handler. So Kaprenter understand this instance is going to be like take away, like it's out of our responsibility. We have to request a new one. Maybe it will be on-demand instances, maybe in other spot instances, depending on your requirements and request. Currently, you don't need to do like it's on Kaprenter, so it's fully managed based on the Kaprenter with spot interruption. Very important part. The next one, it will be related instance size. Maybe you have reserved instances, maybe capacity. You paid for capacity reserved and so on. It's like maybe for you, more preferable instances will be M5X large, double X large, or I don't know, depending. Also, you can select what availability zones. Kaprenter can work very good with PV and PVC. So, for example, you have your own instance and required PVC. And we remember PVC is EBS volume. EBS volume it's related to availability zone. So it means like if I run new instances, Kaprenter understand EBS volume based in availability zone 2A, and I have to run only on 2A. Or, for example, you have your own default amount of availability zones. My recommendation, make sure that you have at least 2. The best practice, it will be 3 availability zones to spread your load, because availability zone, it's only one part of region. All regions have at least 3 availability zones. Taints, so startup taints can be very useful if you have your own network interface and you need some time to prepare this network interface. You can define startup taint for this instance, and after that, it will be your responsibility to remove this startup taint to make sure that you can run application inside this node. how we can manage where to run my pods. Remember, not selector, like it's super easy. So you see like not selector, availability zone, my capacity type at spot. Also, Kaprenter can work very, very great with not affinity, anti-affinity, like all of your expressions, just like where to run, how to run. It's covered by Kaprenter in very great way. Consolidation. I think it's one of the most interesting feature from Kaprenter because it's not statical way that's, like I schedules, I run these nodes and live with these nodes like for the next many, many hours or days. Kaprenter continuously try to understand that maybe I can find the best way how to spread this load in my Kubernetes cluster. Maybe I can request new type of resources or merge some of the resources. But be very, very careful. Make sure that you have pod disruption budget, just to make sure that you will not lose your whole application. So remember, we can schedule some pods on some nodes. And for example, for some reason, Kaprenter decided to remove this node and all of your application based on this node, or just like in some amount of the nodes. Pod disruption budget can help you to avoid the situations that you 100% remove all of your application. Your application currently is not available. So how this consolidation, this optimization works? So let's look at this example. I have 4 nodes. One of them is like, let's say, very busy, 4 pods. It's like this is the right amount of pods, what I prefer to see on this X large instance. And I have another 3 nodes. One of them is like 2 pods, and 2 of them just like only 1 pod. And I said my disruption currently, it's consolidation policy when underutilized. So what I can do, so it's my perspective, I can remove this pod from this node to this one and repeat the same one and remove these 2 nodes. So, and Kaprenter will do it. So Kaprenter will run, like simulation, understand, so, hey, I can fit this load just on 2 nodes and remove other nodes. And that's what happened. So Kaprenter makes this optimization. Another example. So almost the same, but you see a little bit, we have the same type of the instances, but currently our load is only 2 pods. But we don't need X large. So if I can create, for example, separate large instance, it will be cheaper. So it means like I will not pay for the whole X large, like double price. I can put it only in one node, and Kaprenter will do it for us. So it will request new instance, which will be large, double size less compared to X large, and put these pods inside in this node. So when we pay less, cheaper, because it's like we don't need these resources. Yeah, so why we have to pay all of them? Also, you have a capability to manage your kubelet configuration. Maybe you need to work with cluster DNS. I don't know. Maybe you have some separate requirements for container runtime or some resources, or how to proceed with eviction, soft eviction, hard eviction, many configurations. One of the typical question, how I can make sure that I can spread my load between different nodes, and exists like pod density. So how to spread between different nodes and not put everything in one basket, like how I call it, like all eggs in one basket. So there are 2 approaches. The first one is dynamic pod density, when you put it based on amount of the cores, like in this situation, 2 pods per 1 core, or maybe 20 pods per core. Remember, we have limitation related to the network. So how many network IP addresses you can have, depending on the size of the instance. This can help you to proceed with this problem or this challenge. Another one, you can just like statically say, hey, 20 pods per node, and that's it, not more. Please do it for me. And here we go. We will see also in the demo. I will show how it will be proceeded by Kaprenter. And demo time. I'm a big fan of demo. Why? Because slide is great, but it's much easier, for example, for me to understand how it works when I see visually how it works. My demo, it's based on this GitHub repo, it's QR code if you want to repeat by yourself, but be careful because I'm going to run a lot of instances. It's just like for demo to demonstrate how Kaprenter can proceed with big, like high load performance, like so on. What kind of the scenarios we are going to have? It will be two different environments. The first one, I call it like Karpenter 01, where we are going just like to run and see what's really happened under the hood, how Karpenter requests our resources, how it consolidate. We will see, I hope, live, how it's like, like merged together. Also, I will try to do these experiments. Again, it's like a very common question from customers, how I can run my load and spread between on-demand instances and spot instances, because we remember spot instances can be requested by other customer who is ready to pay on-demand price, and how I can make sure that I will not lose my application, like to spread between spot instances and on-demand. Like in my case, it will be 50-50. Another one environment is like I called it like high load or performance environment, where I'm going to run 3,000 pods and spread them between different deployments. Every deployment will be 500 pods per deployment. My goal to show you how it's.
I'm looking forward to it. Sorry for interrupting, but yeah, I'm looking forward to it.
We can run more if you want.
I think 3,000 is enough.
Okay. Main goal to show efficiently, like that we request the right amount of resources. Okay, let's go. I think much more interesting will be to look at the environment. So first of all, what I have two clusters. Currently, it's demo 1, you see, demo 2. It's like two parts of my demos. What else I have prepared? I have Cloud9, where I prepared all of this code. We'll run through my Cloud9 environment. Also, I have a tool which is called KubeOps View. It's a visual tool, like a web visual tool, but looks like it's a terminal way visual tool. It helped me to show how many nodes I currently have, how many ports I have. And I understand it's a little bit maybe small. Let me try to make it a little bit bigger. So, but I'm not sure. Yeah, so you see what the size currently of the nodes. For example, this one is C5 2x large. By default, when you deploy your Kaprenter, I already done it. So I mean, like I have my Kaprenter inside in this two Kubernetes cluster. I will show you just like in a few seconds. And I requested two nodes. Why two nodes? Because you need to spread it between two nodes. If you lost Kaprenter, you lost how you manage your environment. So be careful. Make sure that you have at least two nodes for your Kubernetes cluster. For your Kaprenter. The same environment, absolutely the same. I call it like high load, the same amount of nodes, as you can see, almost the same configuration. And what I'm going to do. So I will start from second environment because it will take some time to run this 3,000 of pods. It's what Pavel waiting for. But yeah, so I have super complex bash script. What the bash script is going to do. So I'm going to provide a parameter how many pods and what's the batch, what's the size of every deployment. But to make sure that it have different configuration, when I say different configuration, I mean request different amount of resources. So I have like array for CPU options, like 250 millicores up to 2 CPU, and the same like from memory perspective options. So, and it will do like, like random connections, 250 millicores, maybe can combine together with 1 gigabyte of memory and so on. So let's try to do it. So I have my bash script, which is called create workload.sh, 3,000 pods, and spread them between 500 pods per deployment. Let's try to run it. It's takes some time, just like what I want to show is like we will have all of this deployment currently in place. So here we go. Let's just double check. Let's look what the deployments we have. Yeah, you see it's batch 1. It means like 1 CPU, and it's combined with 500 megabyte of memory and like other combinations. So it will take a time just to up this pods. Let's back to our first environment. Just like currently, we want to run just like super simple deployment. Let me show you what the deployment will be looks like. And again, I will do, like some comments. So this deployment, it's inflate with super simple 10 replicas. Not so many, but 10 replicas. Let's start from small size. What I also have, I have only requested resources. I totally understand that on a production we can request these resources, but in reality consume much less. But for the demo reason, I just use request. But my recommendation will be to you have to identify your request and limits. And it's the best way if you can put it together, request and limits, the same value. So, for example, currently I have 250 millicores, and maybe for your application it will be requested and limits absolutely the same. It will be the best way how to you make sure that your application will never evicted from this node based on quality of service what's provided by Kubernetes. You can find this on official documentation of Kubernetes, QoS, and depending on your configuration request and limits one. Anyway, what else I have? I have not selector, it's spot. So I want to save some money. So I'm going to run this application inside on the spot instances. And my application, it's like, will do nothing. It's like pause application, just run this pod and that's it. I totally understand, but it's a demo. Let's do it. First of all, let's check what the deployments do I have currently in my default namespace. I have kubeops view. This is how I call this tool. Let me show you this tool. This one. So it's show me like my 2 nodes. You see kubeops view and Redis looks good. Okay, let's try to apply this deployment. Apply -f, and it will be 0, 1, something, 10 pods. Here we go. And now if we back to our visualization, so what's we currently see? We see, like some amount of yellow blinking pods. These pods currently in pending state. So if I just say, hey, Kubernetes, can you please give me pods? We'll see some of them, it's currently pending. Pending, it's event when Karpenter or cluster scaler start to request new resources. So we currently have this 10 pods. We don't have free space. Yes, we have like some space, but I said, please run my instances only on spot. And 2 instances what I had previously, it's only related for Kaprenter. It's like where I run Kaprenter, and I'd want to avoid situations that I schedule something where Kaprenter based, because I can have been situations that my application will evict my Kaprenter. So also, please never put your workload where you have your Kaprenter or other some system applications what's required to proceed with your Kubernetes cluster. Let's back to visualization parts. Here we go. We have all of my 10 pods inside in this node. What's the node currently? It's C5A X large with 4 CPU. It's application not amazing because I cannot move. I believe you can see it. I hope. It's like it's a little bit below 4 CPU, 8 gigabyte of memory. Cool. Great. Let's imagine situations that I have, for example, HPA, horizontal pod scaler. And currently I have 10 pods, but I decided to scale out and requested additional 50 pods. So in my situation, it will be replicas 16 for the same deployment. So let's try to do it. Here we go. And now if we try to get the same pods, we will see some of them. It's like currently in the pending. Let's do a little bit maybe in the best way, just like to get deployments. So you see 15 of them are available. So it's ready. Why? So scheduler understand I have some free space here, and I can schedule, for example, 5 of them on this this box on this node and put it. So, and another one is just like currently blinking. You see, here we go. It's Karpenter currently understood how many resources do I need. Let me try to show you. I will do my best. So it's a logs. Somewhere here should be. Yeah, here we go. So I need some resources for 15 CPU. This amount that you see in millicores and in the memories, and so on. And let's look on the visualization. Currently, I run this node, but it's a great tool. It can help me. Here we go. It's what's currently happened. It was consolidation. So let me explain what's exactly currently happened. You can see this. Let me show maybe in this way. You see this is red line. It show me CPU. That's how much CPU I need currently requested, not consume, but requested on this specific node. And previously, it was not enough utilized on this node. For that reason, Kaprenter runs this consolidation, understand, hey, I can put all of these ports, what is based here, it was 15 ports, if I right remember, and move all of them to this node. And what's currently happened? Here we go, it's a magic. Kaprenter just deletes this 3 node, where we initially run our 15 ports. But currently, the utilization of this node, just like have a good way level, you see it's here, so like good percentage and so on. What's the size of this instance? Let's look. It's 4x large with 16 CPU and 32 gigabyte of memory. So like just like currently remove this ports from previous node and just like remove all of them. Okay, this is how Kaprenter and consolidation works in action. Second part of the demo, if you remember, I'm going to make to spread. So what's the goal? The goal is try to create like 50-50. For example, some amount of ports will be like, for example, spot, yeah, and some of them it will be demand. Oh, as usual, I want to save some, like make sure that it's nobody will take this node. So I want to use a Kaprenter to spread them between a different pricing, different type of the nodes, spot and on demand. So first of all, what I'm going to do, I don't need these logs. Let's delete my deployment. Delete deployment. My deployment is inflate. Here we go. And you remember I said for Kaprenter we have node pools. Currently, I have default configuration. Let's look what's inside in this default configuration. Sorry, YAML. Here we go. So it's configuration by default, like what's I prepared. So first of all, for every node pool, you can configure limits. In my case, it's 1K, 1000, just like for demo reason. But you can configure it up to you. Like, for example, you have different teams. Maybe for one application, it will be more than enough than like 100 of CPU to proceed on this node pool. What else I have? I have expired after. It's very important part because this node will be expired after 1 month, I would say, and we will like run new one to make sure that we have the latest security update and all of the stuff, because sometimes we just run some nodes and forgot about them. So it's very important to make sure that we have the right node with the latest security updates. What else we have here? It's my architecture, it's Linux, and type of the capacity. It's only spot instances and so on. Currently, it's only spot instances. So looks like I have to create new node pool. Let's clear it. And I already prepared 2 other node pool. And to show you, like, not like a magic, but I hope you will understand. So what I have currently, requirements on demand. We see it's on demand, good. There is like a little bit as a magic. It's custom definition, like capacity spread, and I just add as a values like 1, 2. This is how you can manage it. I mean, you can define, for example, 3, 4, 5 here. Let's say like 3, 5. And in total, you have 10 numbers. It's how you can control how many will be on demand, how many of them will be spot instances. It's just based on these values. I will show during the deployment how it's spread it, how it's try to make sure it's spread between these different nodes. Also, you see, I statically defined amount of pods per node. In my situation, it's 30, so not more than 30 pods per node. Because previously we saw that in one node we run all of our applications, like 60. But for web application, it's a not good way to have only one node. It will be better to spread it between different nodes. Okay, the next one is spot instances, absolutely the same, but the value, the difference here is like 3, 4. Also, for sure, its capacity type will be spot. And let's run this node pools Kubernetes apply -f no 0 to 1. It's my on demand. Apply -f 0 1 0 0 2 0 0 spot. Here we go. And also I need to delete my node pool default. Here we go. And also I'm going to apply my new deployment. I will run it and show what will be inside in this code. Let me show you. So in this time, I'm going to run 600 pods, not 60, but 600. Why not? And the magic here, it's related to topology spread constraints. I said max skew 1, and Kubernetes will do their best to spread the pod between different nodes with this custom label topology key, which I defined capacity spread. And you remember I have for on demand, it was 1, 2. For spot instances, 3, 4. For example, if I said like 3, 4, 5, so it means like it will be a bigger amount of pods will be scheduled on demand, but less on spot, but less than on demand. So this is how you can control. My practice, and I believe you will see just like in a few seconds, you will not have like 50-50. You will have like something, but it's tried to their best of these numbers. Let's see from visual perspective how it looks like now. So we have much more nodes currently. Some of them still it's try to scale something. It's up and running. Also, important part here currently it will be dynamically try to Kaprenter will run consolidation constantly to make sure that we consume the right amount of nodes. So maybe we can just like remove some of them, make it cheaper. And honestly, I currently expect that we will see more spot instances rather than on demand. Let's try to look how many of them total we have. You see, it's just like I run my nodes using the labels to show my capacity type currently on demand, spots, on demand. Some of them it's empty. This is empty. It means like where I run my Kaprenter. Let's try to count. So currently I just show you, but let's try to count and use a magic of bash. So I'm going to make a grep demand, for example, and count wc -l. And here we go. We have 9 instances on demand. And let's see how many of them will be spot. And 14 spot. So why this happened? So first of all, again, maybe it's related to like how in general it's how Kaprenter proceed with consolidation and to make sure that it have the right amount of nodes, and then like it's more optimized and cheaper than other one. So again, like from visual perspective, it looks like in this way. And we spreaded them like some of the nodes you see here. It's like 4 CPU, some of them 8 CPU. It's also 8 CPU, 4 CPU, 8 CPU, just like different nodes, different size of the node. This is how we try to achieve, like to spread between spot instances and on demand. You remember, we also have this in other environment. High load performance. We have 3,000 ports of them. So, most interesting part. Let's look from visual perspective. Here we go. 3,000 ports currently in my cluster. I believe you don't believe me. Yeah, let's try to get all of the deployments and see what's going on. And here we go. We have all of them is ready. 15 minutes ago, you just can count how much time it took to schedule and run all of these 3,000 ports. So here we go. It looks like on this way. So this one is C7I with 192 CPU. Pretty small instance. Yeah, pretty small, I think so. This one, 120.
Yeah, I will not try it at home.
Don't try it home with your personal account. Yeah, it's 100%. This one, for example, it's on demand. You see, on demand, it means like it was not enough super great demo. Super great, because I said only use spot instances, but looks like currently in my region is not enough spot instances, and it's not good demo. It's I got it. It's scheduled my ports on the instance as a Kaprenter, so I made some small mistake. I think so, but anyway. So you see different sizes of the instances. Most of them it's 128 CPU. For some reason, maybe because it's much cheaper compared to other. And what I want to show you, efficiency of usage of these resources. And I'm going to use plugin for Kubernetes, which is called resource capacity. And let's see of CPU requests. So we currently see it's currently as utilization 98%. So Kaprenter do their best to make sure that we have this number 98%, and most of the instances you can see it's 99. Some of them just only one, it's 89, but most of them it's 99. I know, I understand. Maybe some comments or some people already started to write a comment. Hey, you don't consume anything. Kaprenter works with request resources, and your goal to make sure that you have the right request and limits. So make sure that you have this number correctly. But anyway, so from request perspective, we have 98%. It's how we consume these resources. Okay, I don't want that my manager will come and say, "Hey, Victor, what are you doing with Kubernetes? Why you spend so much money?" Let's remove all of this stuff. Again, I will use my amazing bash script. It's just identify. Let's show you duplicate deployments. So what the bash script will do, just get all of the deployments. We started batch and just delete it. Let's do it, because I don't want to have escalations that I spend many money on AWS. So here we go. It's just delete it, and let's look from visual perspective. Some people said, "Hey, you just delete it," and if you try to get it, for example, get deployments, it's nothing. Why I still see in visual perspective this spot? In reality, if you go inside in this node, you will see that it's currently in a process to remove this port. So for the kubelet for API server, it also needs some time to proceed with this deletion, just remove these ports from this node, because this node has many ports. I don't know, couple hundreds of them on per node. So for that reason, it took some time. And currently, we see it's less ports. And my goal also from this demo to show you how quickly we will remove resources which we currently don't need. So currently, you see, we almost delete all of the ports from this 3,000 nodes, 3,000 ports, and it's it will take, I know, maybe 1-2 minutes just to remove all of these ports from my environment and don't pay for them. This is a demo. of Kaprenter, how Kaprenter can proceed efficiently with resources, with like your environment inside in Kubernetes, and how you can, I would say, can save a lot of money if you just migrate from cluster scaler to Kaprenter. For sure, like 100%, if your environment not so dynamic, like you have, I don't know, 5 nodes and that's it, and you never change it, I mean, like nobody scale out, scale in, yeah, Kaprenter will not save money for you. But if you have like some dynamic environment and your workload moving up and down depending on day of the week, depending on time of the month, depending on time of the day, like so on. So you see in action how it can scale out, scale in, scale up, scale down, depending on what's kind of mechanism of scaling you use inside in Kubernetes cluster.
Amazing, amazing. One of the best, if not the best, demo I ever saw. So thank you, Victor, for showing this to us, because it was like real scenario. Of course, without the load, right? But anyway, right? So it was the real scenario how the properly configured, or as you said, almost properly configured cluster should work. But generally, yeah, that's what we saw, and we see right now that number of nodes is 2, back to 2, and few pods are in the
in the process, just like removing. It's insight and visual perspective in this, like this tool.
Yeah.
I cannot recommend this tool to use in production to control and monitor your environments. It's mostly, like to see from like a little bit visual perspective how many nodes do you have and so on and so on. It's not a monitoring base. It's just visualization.
Visualization. Yes, and that's enough, right? So monitoring is one thing, and this is like a helpful tool for us to see how we look, really, right? And not use kubectl, but this tool to see it. Great. Really, I really appreciate your time spent on this demo and showing us this. I believe this will be very useful for many people, and it is for sure useful for me, because I saw a few things which I wanted to see how it works really. From the question perspective, if I may ask you, well, we saw how quick Karpenter is with scaling the nodes, right? Did you saw in your experience like very high peaks of the load, which are hitting the cluster, and the cluster was not able to scale fast enough, or it's not the case here?
You can have a problem if you have limitation of amount of resources inside in your EC2 instances. Also, yeah, Kaprenter make a lot of API requests to EC2. So just to make sure that you just like you scale on the right way, because I saw the situation that sometimes people create, we can overload our EKS control plane. I would say not Kaprenter, but EKS control plane, because sometimes when we create custom resources and this resource is like super dynamically up and running, do some stuff, blah, 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 it can overload of amount of API requests to Kubernetes API. And from Kaprenter perspective, we can see this limitation from EC2. Anyway, like cloud, it's great, but everywhere we have some limits.
Of course.
API requests, it's also limits to EC2 API, just to make sure that you don't have, like you don't schedule like every 5 minutes thousands of requests to up and run in your application. You have the right, like reasonable. If it's not enough, just work with support to make sure that you have the right size of API limits, the right size of your control plane. Sometimes also can help, and so on and so on. Yeah, but I saw a problem, but it was related to version 0.20, 0.15, that sometimes people do some stuff with Kaprenter during the update, and Karpenter lost control of some nodes. That's happened. I know some people complain about that. Also, some people complain about that we have this timer when the node, some node is live, and at some period of time, just like remove all of them. Again, pod disruption budget. It's your way how you can save your application and control amount of nodes currently not available. And also look at the size of the Karpenter. By default, like a recommendation from documentation, 1 CPU, 1 gigabyte. But for example, for my demo, for these 3,000 nodes, I understood it's like can be a little bit too much. I requested 2 CPU and 2 gigabyte of memory, and it was more than enough.
Sure. And so in this case, we came back to the most important element in IT, right? The proper architecture, proper configuration.
Absolutely.
And this is something what we have to have here, not somewhere else, right? And at least in documentation, and to know where the documentation is. Right, perfect. Viktor, I don't want to keep you for longer. It was really great demo, 2 demos really, or maybe even 3 demos, right? Because we saw a couple of things there, and we saw the real scale. It was not done on 1, 2 pods. It was done on 3,000 pods, and you could easily go further than that.
Yeah, absolutely.
But well, I know why you didn't. Probably your manager will come faster than you expect then. Anyway, thank you very much again for your time. Thank you very much for showing us this Karpenter and its abilities. For sure, it was helpful for me and helpful for others. And I believe we stay in touch, and I will invite you again soon, sooner or later, to talk about new things. Probably in Karpenter, because this is something what is growing. Maybe some AI will be there. We'll see, because AI is everywhere, right? So it must be everywhere. And yeah, what can I say more? Thank you again. I
You're
know I'm
welcome.
repeating
You're
myself.
welcome. I hope you, our audience learn something new, and we'll try to play with Karpenter. If you already have a cluster scaler, we have, and honestly, Karpenter have very great documentation. Look at that. And if you have cluster scaler, look how you can migrate from cluster scaler to Karpenter. And
yeah, do it. Do it. Let me know. Let us know really in the comment section how it works for you, how big workload you run using EKS and Karpenter, and let's have a discussion about that. Viktor, thank you very much. I'm giving back you to your other tasks, and have a great weekend, because we are recording this on Friday, and see you on reInvent.
See you on reInvent. Thank you very much.
Thank you very much.
Bye.